All right, today we are diving into one of the absolute biggest challenges in tech, AI alignment. It's this whole art and science of teaching a really powerful AI to be a safe, useful partner for all of us. So let's open up the playbook. I mean, this is really the multi-billion-dollar question, isn't it? How do you take an AI, fresh off the digital assembly line, and actually teach it to be helpful and honest and harmless? Well, that whole process is called alignment, and it's a pretty fascinating journey from just raw power to a genuinely refined assistant.
Because, you see, a base model, it knows a staggering amount. It's scraped the internet, it's seen all the patterns, the facts, the language, but it has zero inherent sense of purpose. No instructions on how to interact, and absolutely no concept of what it should or should not do. It is all horsepower with no direction. So, how do we install that steering wheel?
Okay, so where do you even start? Well, you start with the most intuitive step you can imagine. You teach it just like you teach a person, by showing it countless, and I mean countless, good examples. This first phase is called supervised fine-tuning, or just SFT for short. Think of this like a gigantic set of digital flashcards. Seriously, on one side, you have a prompt, maybe something like, explain photosynthesis, and on the other side, you've got a perfect human-written answer. The AI's whole job is to just study thousands and thousands of these pairs until it learns to imitate the style and the quality of those ideal responses. But here's the catch. SFT is both completely essential and pretty limited. On the one hand, it's a cheap and stable way to give the AI its basic personality, right? But on the other hand, it can create an AI that's kind of brittle. It struggles with new topics it hasn't seen, and sometimes it imitates the training style a little too well. So it's the perfect foundation, but it's really clear we need to build something more powerful on top of it. So, if simple imitation isn't enough, what's next? Well, the solution was a true landmark moment. Instead of just showing the AI good examples, we give it a coach. This next phase is called reinforcement learning from human feedback, or RLHF. And at the absolute heart of RLHF is this brilliant concept, the reward model. So instead of having humans write perfect answers, which is really hard, we just have them act as judges. For any given prompt, the AI generates two different responses. A human simply picks the better one. That's it. After seeing thousands of these judgments, we train a separate AI, the reward model, to basically act as a proxy for that human judge. And this all comes together in a three-step pipeline. First, humans just pick the better of two AI responses, again and again, creating this massive data set of our preferences. Then, that data is used to train the judge AI. That's the reward model. And finally, the main AI is just set loose to practice, constantly trying to generate answers that its AI judge will give the highest possible score. It's this continuous feedback loop that's designed to just chase human approval. And the results, they were staggering. The famous InstructGPT paper showed that a much, much smaller model trained with RLHF was actually preferred by humans over the gigantic 175 billion parameter GPT-3. This was revolutionary. It proved that alignment, teaching an AI to be helpful, was just as important, if not maybe even more so, than just sheer computational power.
Now, RLHF is powerful, no doubt, but it's also incredibly complex. We're talking multiple models, tricky engineering, the whole 9 yards. So naturally, researchers started asking, is there a simpler way? And the answer, it turns out, was a breakthrough called Direct Preference Optimization, or DPO.
And right here, this is the aha moment. DPO's magic is just its simplicity. It completely throws out that complex RLHF pipeline. There's no separate reward model to train, no tricky reinforcement learning. It is a really clever, direct approach that learns from those good and bad response pairs in a single, efficient step. It gets you to the same place, just without the crazy detour. The result is just pure elegance and efficiency. DPO is cheaper, it's faster, and it is far more stable to train. So it's really no surprise that for a lot of teams, this is now the go-to method for alignment.
It delivers great results without that massive RLHF headache.
But what if your bottleneck isn't complexity, but the sheer number of humans you need to provide all that feedback? Well, that's where the next evolution comes in, constitutional AI. This is where we start teaching the AI how to teach itself. The core idea is to give the AI a set of principles, literally, a constitution. So instead of a human judging its output, the AI uses this constitution to judge itself. This example here is a simplified version, of course, but you can see right away how it provides a really clear guideline for behavior.
And this creates an incredibly powerful self-improvement loop. The AI generates answers, it critiques them based on its own principles, it revises them, and then it learns from its own critiques. This whole process, called reinforcement learning from AI feedback, or RLHF, dramatically reduces the need for human labelers. It allows alignment to scale like never before. So we've got SFT, RLHF, DPO, and RLAIF. Each one is a powerful tool, right? But they are not interchangeable. The final piece of this whole puzzle is knowing when to use which one.
And this playbook just ties it all together beautifully. Look, you almost always start with SFT to establish the AI's basic persona. From there, if you have the resources and you really need the AI to learn complex new skills, RLHF is your powerhouse. If you need to move fast and you're on a budget, DPO is your absolute best bet. And finally, when you need to align at a massive scale without relying on thousands of human reviewers, well, constitutional AI is the future.
And that brings us to our final thought. This journey from SFT to constitutional AI shows a really clear trend. We're reducing our reliance on direct human oversight in favor of these scalable, AI-driven methods. Now, this is incredibly powerful, but it also leaves us with a pretty profound question for the future. As we hand the AI its own rulebook, how do we make sure it doesn't drift and that its interpretation of those rules always remains in harmony with our own human values? That's the challenge ahead.